Okay, so continuation of Group 7 element section. This is question 3. This is asking us to look at the reaction between chlorine water and an aqueous solution of potassium bromide. And it's asking us to complete the word equation. And so what's going to happen is chlorine, as we've already looked at now, is more reactive than bromine. It's higher up Group 7. So the chlorine is going to kick out of the compound the bromine part of the potassium bromide, and that is going to leave us with a potassium chloride compound as the product, as one of the products. So potassium chloride is going to be one of them, and that is then going to kick out bromine as the other product of that reaction. Now, when we do that reaction, what we would then observe is the release of the bromine over here. Now, bromine is a very characteristic compound when it goes into solution, and it gives a very distinct orange coloration. So what you would see is an orange solution formed. The bromine is very, very characteristic when it goes into solution. The other products in the reaction, so the potassium chloride is clear and colorless, as is potassium bromide, and chlorine, pale green at best. So you're not going to see any distinct colors from those other three reagents, but bromine is going to give you, as I say, a very characteristic orange solution. Now, the name of this reaction, as we've probably already discovered, is a displacement reaction. The chlorine has displaced the bromine, and it is literally just called a displacement reaction. And if we then look at the final question, it's asking us, is the chlorine water going to react with potassium fluoride in the same way? Now, the simple answer is no. And the reason this time is we're trying to displace the fluoride from the potassium. And this time, chlorine is not strong enough to kick out fluorine, or the other way around. Fluorine is more reactive than chlorine. And so what we don't see is a displacement reaction, as we saw in the bromine case.